Okay, 1.8, number 11. They want us to find f plus g, f minus g, f times g, and f divided by g, and what is the domain of f divided by g. Okay, well, the first one says to add them. This is quite important, actually. I'm glad we're doing it now. F of x plus g of x is what that notation means. So we simply write 1 over x plus 1 over x squared. And you can see that the LCD is x squared, so I'll put some bubbles in if you remember from class. Okay. Alright, so the LCD is just multiply them if you have to. You can say x cubed, but we should realize that a common denominator would be x squared, so I'll multiply by x here. Remember, that's some form of 1 to make x squared. And here, just 1 over 1, because I already have the x squared. Okay, since I created the lowest common denominator, I'll just write it. And I get x, because x times 1 is x, and 1 times 1 is 1. So we get x plus 1 over x. Okay, let's do the next one. F minus g. This is just a good exercise for you in working with fractions or rational expressions. I think it's 1 over x again, just minus 1 over x squared. And if you get a little bit faster, you don't have to play the bubbles, you just get used to the game. So this guy needs an x. He doesn't need anything, so that's x minus 1. The next one is f times g, okay, of x. So that's f of x times g of x, which is just 1 over x times 1 over x squared. And you get 1 over x cubed. Remember, when you multiply two numbers with the same base, you add their exponents, okay? And finally, we have to divide them. If there's anyone that's interesting, it would be this one. So that's what? 1 over x, little division bar, big division bar, x squared. Multiplying by the reciprocal, that's 1 over x times x squared over 1. And, I mean, whatever you need to do to get x is fine. What would the domain of this thing be? Well, you did cancel, so you should say that x does not equal 0. In calculus, we'll call this a removable discontinuity. You don't need to know that yet, but it's true, because I can fill that with I could fill that hole. So anytime you cancel in a graph, what happens is either a situation like this where there's a hole, and there's another situation, but that's too much information. So we'll just leave it there. You don't need to know that, but it's cool to hear. So okay, here you go.